Hi everybody, this is Mrs. Ellsworth, and this is our very first lesson in math. Right away, our book wants to jump into problem solving, word problems, and that sometimes tends to make us a little bit intimidated by the more words it is, it seems like the more intimidated that students are, and sometimes myself too. That's okay. What it is important is to break it down. Sometimes word problems, I love it when they have a graph or a table, such as this right here is a table. And I like that because I like reading data. I like when it's stacked up like that or else in a graph so I can see it and interpret it, and then I feel like I understand it better. Anyway, probably one of my biggest failures that I personally have with word problems is reading. I need to read it carefully. When you go and look at how our book goes and organizes, they want you to do a 4-step plan. Understand the problem, come up with a plan. Okay, so that's telling you to come up with an operation like subtracting, adding, multiplying, dividing, such like that. Then they want you to actually do the math and solve it. And then a big one, they want you to check your work. Okay, so let's go ahead and look at this plan. So when you understand it, okay, you read the problem quickly to gain a general idea about it. What facts do you know? And then what things do you need to worry about? And what things can you just cancel because it's not important? Okay, reread the problem again. Identify relevant facts. Again, you're figuring out what do we need to use, what can we throw out. Determines how they're related to each other, and I'll talk about that. And then you can figure out a plan to solve it. And you estimate it. Estimate it so that you can figure out if you're even close to the right answer. I always estimate at the end, so I can double check my work and make sure that it's right. And I say always like it always happens. I always so mad at myself whenever I don't remember to check in the end. So try really hard to get into a habit of that. Then solve. You use your plan, you solve the problem, you do the right operation, and you figure that out. If your plan does not work, then you need to revise it and do it all over again. That kind of reminds me of science when we go and we test a hypothesis that it may not work out right. So we have to go back, replan, come up with a new one, and start all over again. And then finally, reread the problem. I have to double check and make sure that I read that very last sentence. It's usually a question or else a sentence. And it tells me what's specifically needed. It seems like quite often in most of these problems. And then I can tell myself whether or not I answered that question. Okay, so let's jump into this. Go back to that problem. Okay, so about how many times as great is the number of teens who use their cell phones to take pictures compared to the number of who exchange videos? Use the 4-step plan. Well, let's just go and look at this for a second here. So in this data table here, we've got a whole bunch of teens. Okay, and you can read it. Some are access social network sites, some exchange videos, some play games, some play music, some take pictures. Some may even do all of those. It doesn't tell you that specifically. They just ask how many use each type of operation there. So you notice that I underlined this one first, or I highlighted this first. About how many times is great. If I had 24 students in one class, this is just another idea just to break it down for you. If I had 24 students in one class and 12 in the other, my class with 24 students would be 2 times as great as the other class. Twice as many. 2 times as great. So that means that we're going to take the big number, 24 students, divide by the small number, 12 students. So that's what we're going to do here too. Did you notice I used another example to help me make sense out of it? Well, quite often when they have times, it seems like you have to do either the opposite operation or else you have to do this operation. So that's just one way of looking at it. Notice the word about also. Whenever you see about, that usually means you got to estimate. What does estimate mean? It means you round the numbers that you were given in this table to where that you can do easy in your head math. Okay, don't have to use a calculator because you know your math facts, so that works. Anyway, so let's go and start breaking down all the pieces. So it says, about how many times is great? Notice I'm rereading again. About how many times is great the number of teens who use their cell phones to take pictures and then compare it to the number who exchange videos. Okay, so what I did here is I went and, since it says about, I know I estimate, that means I round these numbers. So I rounded 177 to 180, and I rounded 61 to 60. So I know 18 divided by 6 is 3, and 180 divided by 60 is 3. So it's 3 times as many took pictures to the number of the exchange of videos. Okay, now I want to check my work. Now, sometimes, you know, it's pretty simple work, like we're just dividing here. So why don't we go and take our 3, why don't we go and multiply it by 61 and see what we got. Okay, so 61 times 3 makes 183. Okay, 183, which is close to our estimated number, so that works out pretty well. Okay, so what I do, I did the opposite operation here. Instead of division, I did multiplication of my 2 factors. Okay? Okay, that's one type of problem. And a big thing there that I sometimes skip when I don't read my best is that I miss the word about, which means estimate. Okay, here's number 2 of your word problems that you'll have for homework. Okay, at the 2010 Olympics in Vancouver, Yuna Kim, she scored 228.56 points in the women's figure skating. Akiko Suzuki scored 180.44 points in the event. About how many more points? How many more points? About how many more points? Boy, there's all kinds of words there. About means estimate. More points, so we're going to be subtracting. Okay, did Yuna Kim score over Akiko Suzuki? So let's write this stuff down. We know that we've got an estimate. Okay, and it says how many more points also. So that's important because that means we need to subtract. Okay, and so we can do that. But again, we estimate. So we round those numbers to nice numbers because I don't want to line this stuff all up, right? You don't want to when you don't have to. And there we go. We're going to round this one to 180, this one to 130. We'll subtract 2 and we'll get 50 points. So when you estimate stuff, you're basically saying, oh, basically it's about 50 points. Just rounding it all up, right, before you go and subtract so that you can make simple computations with those numbers. Okay, I'll check my work by doing the opposite operations here. Maybe I'll just add 50 to the 181.4 because I can just change just the one number to 23, 18 to 23. Anyway, so when I add these together, the 5 and the 18, I get 231.44. And that checks out. That's really close to my estimate. So 50 points is my estimate. Okay, so this is really working hard for you to understand the words about and then figure out how many more points. So that means we subtract. Okay. Now, here we've got another one. This is problem number 7 of your homework. Okay, the towns Jackson, Bellevue, Salem, Denton lie along a highway listed in the order listed. The distance from Jackson to Salem is 84 miles. The distance from Bellevue to Denton is 61 miles. The distance from Bellevue to Salem is 18 miles. What is the distance from Jackson to Denton? Oh, goodness. You see all these towns and you see all of these different distances, and that becomes kind of mind-boggling. So I recommend you draw a diagram. Okay, so here's a road. Jackson, Bellevue, Salem, Denton. So now I go ahead and write down all the values that they provided in here. 84 miles from Jackson to Salem is 61 miles from Bellevue to Denton. Okay, and then finally 18 miles from Bellevue to Salem. So there's this 18-mile stretch here that's doubled on these two. So we got to subtract 18 from one. I'm going to subtract it from the top one just because you can pick either one. Okay, so we've got to subtract that 18 from here so we can figure out this distance in this aqua color. Then later on we can add it to the 61 to get the total distance, right? So one way to do this is subtract 84 minus 18, okay, to find out that distance, and then we can add it to the 61. Okay, so that was 66 miles is how long it is from Jackson to Bellevue. And Bellevue to Denton is 61, so we just got to add those two up. I misspelled that. Okay, so 61 plus 60, 66 plus 61 is 127 miles. Okay, so that's the answer. That gives us the total distance that we need. What is the distance from Jackson to Denton? Again, I reread it. Okay, then I'm going to just double check my math. Okay, and what I'm going to do this time is I'm going to just play some number sense here. I'm going to do 84 plus 61, and I get 145. And I'm going to subtract this 18, and I get 127. Okay, that's it. So then tomorrow, when you come to class, we will work on those problems selected. I'll give them to you tomorrow, and then we can work on them in class and ask for help. So I'll see you then. Bye-bye.